Folks, welcome back to another episode of Infinita Conversation. Today we have Ryan with us, and we are diving into what could be I would say, the most disruptive energy tech so far. I think it is because it is something that is totally doesn't have anything moving in it, like, other than electrons, right? It is graphene hybrid supercapacitors. Ryan is representing HyCap Energy that is behind this tech. Uh, when you talk about when I say that the graphene hybrid supercapacitors are something very disruptive, we are talking about HyCap solution that is going to outpace what we know about lithium-ion batteries in safety, longevity, recyclability, and raw performance. We are talking about 20 times the lifespan. We are talking about zero heat, and we are talking about 98% round trip efficiency. 98%. Okay. So obviously, Ryan, I'm very thrilled to have you here.
Yep, thanks for having me here. It's great to be here. I think we've got quite a few topics to discuss. But what you said in the intro is true. We are talking about an energy storage solution here that we are expecting to go 20 times or more the lifespan of the typical lithium that's on the marketplace right now, depending on the application. There's a right battery for every application. So we fit into a certain niche, if you will, where longevity and high C rates come into play. So for the guys that want to discharge, 10, 20 times a day, complete discharges, we are the solution for that type of situation.
Very good. I think what I hear in this, it is not always about the replacement, but it is about the whole energy spectrum, right? So there are applications that are good for lithium-ion batteries, but there are other applications that are good for another kind of technology. Could be supercapacitor, could be hydrogen fuel, and another kind of things could be, good for any other kind of technology. Some places I would say that traditional technologies, that traditional energy sources could not be replaced. So I sort of agree with you, and but I think in order to understand, it is good to have that comparison, right? So let's get straight to it. I want to understand the technology. How are graphene hybrid supercapacitors different from lithium ion?
So,
Why do you think that it is, a better horse to bet on for certain application?
well, for certain applications, I mean, we can talk about lifespan. The lifespan we're guaranteeing over 50,000 cycles. We know that it's going to go a lot farther than that, especially during partial discharges. So you're talking about many years of use by using an asymmetrical graphene hybrid supercapacitor,
Hmm.
because we basically took a lithium-ion battery and mixed it with a traditional capacitor or supercapacitor. So we're almost right there with the energy density of lithium or the high quality lithium iron phosphates or NMCs on the market. We're a little bit less, but our C rate and our longevity make up for it. So there's also a couple different ways we could take that conversation. But when we talk energy density, if we talk the cells themselves, our energy density is lower. But
Hmm.
if we talk about complete modules, for example, a 20-foot shipping container, I can fit more energy in a shipping container than you can with a lithium battery. And a lot of that is because of the UL, because of the specifications on how close stacks can be to each other, how close the shipping containers can be to each other in the solar field. I mean, I think it's usually 12 or 20 feet with lithium iron phosphate, large scale, like the shipping containers. So we're a little bit lower, but we have the ability to discharge rapidly while generating zero heat.
Hmm.
So we have, like, as you know, we have our UL, lots of ULs, cellular and modular level. But as far as the cell goes, our workhorse, which is the 3.2 volt 31 amp hour cell, we had the UL laboratory do an abnormal charge for 20 hours, and that was a 3.2 volt cell at 31 amp hours that was soaked at 300 amps with
Mm-hmm.
no thermal event, no degradation. And that's our limit right now is 10C because that is the capability of the UL testing facility. So if we can find someone that can test at 20C, we might try that in the future. I think I forgot the last
That's
part.
impressive. I mean, I wanted to also touch upon how are you testing the longevity? I think that was, yeah.
So the longevity, my business partners and the manufacturer have this stuff completely distributed around the world in multiple applications, including FAA weather cameras, telecom, cell phone towers. So there are quite a few towers and applications where this has been used for going on 4 or 5 years.
Mm,
Now they're only cycling twice a day or 3 times a day, so it that doesn't really help us get to the end because we really don't know how long these things are going to last. So
mm,
right now there's a third party test going on where the cells are being tested, or they're being cycled up and down dozens of times a day, and we're 6 months into that test.
mm,
All the other cells that went up in this third party test failed within a couple hours because they're hitting C rates that are well above that of the recommended C rate for discharging and charging of a lithium ion battery.
mm,
So by taking the aspects of a lithium ion battery and blending it with a supercapacitor, we are able to charge and discharge rapidly while generating zero heat like a regular supercapacitor, but we also have the ability to store energy where a traditional capacitor does not perform very well.
mm,
So we claim in between 1 and 2% voltage loss over a 30-day period.
mm,
But I can tell you that I disagree because I've got two batteries right here that I designed for the Army that are at the same exact voltage that they were 90 days ago.
mm.
So I think we might be overshooting there. We're just trying to compete with, on paper with what lithium does, but we have less voltage loss over a 30-day period than your standard lithium chemistry.
I would, for the benefit of the people, not everyone is so verse in all the terms. So C rate, when you say C rates, and there is a big difference, right? So what do you mean by that? And could you tell a little bit about that, how you're different and what it means and how you're different? Yeah.
Okay, so a C rate, the C rate is how much you can charge or discharge based on the capacity of the battery, I believe. I mean, someone's probably going to correct me. I'm not the technical guy. I should have brought Doug in here with us. But so if you have, so like I was talking about before, a 3.2 volt cell with 31 amp hours charged at 300 amps, that's 10C, right? 30 times 10 is 300. So that's where we achieve that C rate. Now, most lithium that I know about is recommended to discharge at zero point 0.5 C or charge no more than zero point 0.5 C. So that would be I'm not very good at math, but that would be what would be the discharge rate on that? If we had a 31 amp hour lithium iron phosphate cell that could only discharge at zero point 0.5 C, it would be 20 times less than 300 amps.
Yeah, zero point 0.5 multiplied with 30, right? So it is like
So
15.
what's really cool about our chemistry is that it doesn't care how you treat it. It doesn't have emotions like lithium does. If you discharge lithium or charge it too quickly, not only do you create heat, which can have adverse side effects, you degrade the cells themselves because when
Mm,
you're forcing those cells to work really, really hard, they form microscopic dendrites
mm,
within the chemistry of the battery, which in turn creates resistance, which makes them inefficient and can eventually start creating heat,
that's
which is
correct.
also resistance.
Mm.
So the C rate is I guess to answer your question, that's the max discharge and charge that you're recommended to do. And there is a mathematical calculation where you can figure out what the C rate is going to be of an
It
overall
is it
system.
is 20 times difference, which is huge, and that is very relevant metrics for practical use, practical application. of it
Right.
because
So
charging is very, I mean, especially charging. How fast you can charge actually depends upon that, right?
right, or how fast you can discharge, like we're seeing with these hybrid vehicles. A
Mm,
lot of these automotive manufacturers are having a really hard time with their hybrids because
mm,
they're discharging the batteries too rapidly, and they're taking a cell that could potentially get 5,000 cycles out of it, and they're lowering it down into the hundreds because of the rate in which they're discharging. So
mm,
that's where I was saying that, we're up there, we're awesome, but at the same time, we might not be for everybody. Like
mm,
for example, uninterrupted power supplies. If you only need to put batteries in a room just in case something happens, you might cycle one or two times a year. I mean, you just stick with lead acid batteries.
mm,
But if you want to do something multiple times a day or have a whole bunch of power with a really high percentage of return, that's where we perform.
mm,
Because we're not cheap, we're not extremely expensive. We're competitive with the prices of high quality lithium, especially when we get up to the shipping container size units and our home wall mounted units. We're competitive. But when we get down to the smaller batteries, like automotive start stop batteries or just your general 12 volt, 24 volt, 48 volt batteries, we are a little bit more expensive than what you can find in the lithium marketplace. And a lot of
and
that.
yeah, and that is not the market you are targeting. That is not the right market for you, where, cell phone batteries or your laptop batteries would actually be made for that. But if it is like shipping, I'm hearing shipping of larger application, right, where there is a huge energy demand and you can run it, that is where basically you are becoming good. Or even home batteries, right, wall batteries and all that.
Right.
Uh, so, I mean, I hear you. I think one thing, I mean, I'm kind of technology guy, so I just like to hear about technology a lot, not more. So, what does hybrid, I think you touched upon it, but what does hybrid means in your supercapacitor? And I'm specifically talking in terms of like materials and structures that are involved.
Okay, so when we say hybrid, we're basically talking about mixing a lithium-ion battery with a supercapacitor. So that's where the term hybrid comes from. And
Mm-hmm.
there's been a little bit of discussion back and forth between engineers and some testing laboratories as to what we should actually call this technology. And hybrid supercapacitor is the best term that we could find. And the NFPA agrees. That's why you'll find that we do have our ULs and our federal certifications and our testing is all listed as a hybrid supercapacitor.
So when you have hybrid superconductor, you have also graphene, right, in their
Yes.
nano sheets. So how could you touch upon those things as well? I think your website touched upon that, but you can touch upon those things like how you are when you say that are you the electrolyte is something where you are doing something, or it is like the whole structure is actually supercapacitor.
It's it's the whole thing. Um, and I could go into a technical document. But basically the majority of what's in our cells is graphene. There is still lithium in our cells, but there's a very small amount comparatively speaking. And that lithium is doped in a way that it is not flammable. Right. So we do not have the oxidation layer that is offered in a traditional lithium ion battery, which allows the fire to fuel itself with introducing hydrogen and all that fun stuff. Um, we're basically just using lithium on one side of the cell to assist with the surface area of the graphene, is my understanding. And I could get back to you with a better answer for
No,
that.
no,
But
I think it is very helpful. I mean, I'm just from the point of view of lithium. When you say, I mean, it is helpful to know that lithium is very little because otherwise it has all sort of problems that lithium brings, right? And I'm understanding that the manufacturing is also roll to roll, right? You can scale it, right?
can you say that again? I'm sorry.
The manufacturing is also something that you can scale, right?
Like the size of
Fabrication.
the cell?
Yeah.
Yeah, so we have a couple cells that we're offering right now, and I just had to make a new one, a new smaller one to accommodate for some of our clients that would like little tiny batteries in the the grid scale energy space for electromechanical switches. But basically, we have an 11.5 amp hour cell, which is
Mm.
about the size of a playing card. We have a 31 amp hour cell, a 50 amp hour cell, which is about the size of like a tuna packet.
Okay.
And we have a 71 amp hour cell, and depending on the application is going to determine which cell we choose. Our workhorse cell is a 31 amp hour. We can get a lot of cranking amps. It's got a great temperature range. For the large telecom and data infrastructure guys, the 75 amp hour cell is better for them because
Mm.
they don't need the amperage flowing through. You know, their draw is very low. And those 23, 19-inch, 29-inch telecom style racks can accommodate for those larger 75 amp hour cells. So you run in a series parallel configuration or parallel series or whatever our chief technical officers determine is the best setup for that application.
Mm.
So we can basically cut it however large we want, and the size of the cell is going to determine the capacity.
Mm. And is it modular? Like, you can fit one and then depending upon the need, you can kind of stack it with more and more.
Oh
Uh,
yeah.
yeah.
Yeah, for example, my little 12 volt 11 amp hour cell, I mean it's got four cells in it. It's just it's a 4P or
Mm.
4S, sorry. But when we get into like the 48 volt batteries, like our Group 31 48 volt batteries that we're marketing to the go-karting industry,
Mhm.
um, I mean that's a little more complex of an arrangement of the cells inside of it. But it's a lot like, your traditional lithium iron phosphate or NMC cells where they're stacked next to each other and held into place, wired together into a BMS, and then your output and input, or your positive and negative. So we can really arrange them however we want. I've got that 48 volt or well 14.5 kilowatt hour home wall unit. It's a 48 volt battery essentially. But if you said, "Hey Ryan, I need these in 12 volts,"
Hmm.
that's a very very simple change.
This is pretty nice stuff. I like it. I think I will ask question about safety later, but one question which is coming to my mind is about, data centers, right? Everyone is talking about data centers that are going to be very energy, like you need 24/7 continuity for years, right? And that's very important. So, do you see a role in there and kind of certain advantages of your system versus other systems?
Yes, and my business partners are already working in that space. Um, Not just for having a, a good power supply, but also to exercise what we call time of use or energy arbitrage. Because a lot of these data centers and now with all these supercomputers and AI, even the cell phone towers,
Mm.
when everyone comes home from work and the kids get on their cell phone and their iPads and everyone's using Chat GPT, we see this huge surge of electricity during peak hours, right?
Already, already.
Oh yeah. Because when
Wow.
you go home, if you go on your computer, your CPU is probably running at 30%. I could look at mine right now. But if we go on to AI and we say, hey, let's turn Prady into a turtle on a skateboard, your
Mm.
CPU is going to ramp up to 130, 140% momentarily. And that all translates to energy because that CPU is literally drawing electricity in to make that happen. So then multiply that by, you know, hundreds of millions across the grid. So if we can take that load away from the grid by using energy that we paid for or they paid for to store the batteries during the cheaper hours, right? So if we can come off with a tower or a data center when it jumps up to 60 cents a kilowatt hour, they're using that AI computer and running electricity that they paid maybe 16 cents for.
Mm-hmm.
So we can, and that's the kicker right there for the large scale applications, because not only can they provide a better service, an uninterruptible service, they can do it cheaper. So we start looking at the ROIs that years further down the road than were previously quoted with other battery chemistries.
This is a big problem in the Bay Area, not only for the data center or usage of AI. That is kind of demand, that is huge demand is coming up and building up, but even for the EV batteries, right? So their EVs would discharge. I mean, that 25% of the new car in California are all EVs. So this is a problem that is becoming bad and worse now in the Bay Area. So I see the application there too, that it can kind of shave off the peak demand, right? So it is
Right.
kind of
And with the EV charging thing and the EV car dealerships is an interesting thing because when those cars come over from overseas, they're at like 20% state of charge. So the dealership gets in 100 new vehicles that they want to put on the lot. Now they have to charge 100 vehicles up to 80%. And on top of that, you've got guys coming in with their vehicles for maintenance and warranties, and they all get a full charge as well. So on top of the new cars rolling in and charging, you have all these maintenance vehicles coming in that get a free charge for bringing their car into the dealership. And right now, the grids can't support it. So these dealerships are looking to put 20 megawatts or 30 megawatts of stored energy on their property so that they can buy electricity when it's cheaper and then discharge it into the vehicles all day long without having to continuously pull from the grid, which most grids right now can't support. And
mm,
it's, there's a huge calling for electric vehicles and electric charging right now in the United States, mostly because of the previous administration. A lot of money was put into that.
mm.
And I don't we I think what they're trying to get us to do is impossible. Um, Even with the projections for 2035, I believe, to hit those marks with EVs, we would have to mine the amount of copper in the next 10 years that the human race has done over the past 100 years. So it, there's a lot more that goes into it than just some, petrified salt in a lake. Um, there's copper, there's nickel, there's aluminum, but
Maybe that is what would propel humanity to another planet to mine.
right, yeah, right. So my thing with the EVs, I'm not trying to market to the EV market at this time, mostly because I can't get anyone to talk to me because they look at energy density and they get turned off. I
Mm.
want to find the engineers that are designing and programming the regenerative braking on the EVs and the hybrids because right now the charge rate is based off of those individual, oh God, what are they called? Alternators, I guess. When you brake an electric vehicle or a
Yeah,
hybrid,
yeah.
it turns it back in and
Re
starts
re
charging.
regenerative
Braking.
mechanism. It
Yeah, the regenerative braking. Now, since we don't have our limit to how we can charge is very, very high. So if we can take those regenerative brakes and jack them up to 30 amps or 100 amps versus 5 amps, that's where we could make a place in the EV world. But it's a really hard market to break into right now because all these mass producers of lithium cells are, I feel like they're kind of on a race to the bottom, with pricing and trying to fix an issue with flammability from punctures and introduction of water. They're fixing that with chemical layers around the batteries and foams that they can put in, films they can put in. But at the end of the day, I mean, you still have a battery that if you puncture, you're going to short it out, and you might have yourself a little thermal event there, as we've seen.
Yeah,
Um,
we have seen that. I mean, this is
right.
a good segue into my next question. Lithium batteries have this very nasty reputation, right? A spontaneous combustion, thermal runaway, right? Heat builds up and, crazy things happen, right? So HyCap crushed that, right? HyCap crushed that fear. So tell me a little bit more about it.
Well, that is true, but at the same time, there's a lot of stuff there with the whole fear of lithium that I feel is not really true. And I come from the lithium world. I sell a lot of lithium batteries as well. Um, as There's a lot of really good lithium cells out there. UL cells, when they reach a certain temperature, they purge themselves, they vent themselves, they come off of a circuit to prevent a thermal runaway event, which we can see at 250 or 300 degrees Fahrenheit. So there's a lot of safety in there. A lot of engineers and scientists will tell you that lithium iron phosphate is the safest battery on the market right now. And going off of data and sheet to sheet, they're true. We see issues with lithium when they are taken outside of the specs, like we go back to that zero point 0.5 C rate, or when we puncture them or introduce the internal chemistry of the lithium battery to water. That's when we also have issues. But through my past 4 years of working with lithium and studying lithium iron phosphate, the only thing I've really been able to find with fires are related to outside sources or outside factors, like the overcharging or the chargers, especially where I come from in the marine industry. There's boat fires with batteries. There's been fires on boats since the Vikings crossed, but now we have batteries that everyone knows are flammable. They take the blame, but in all reality, almost all of the battery fires on boats that I've researched have gone back to the charger, or a wiring issue or something of that nature.
Mm.
We don't have them just spontaneously combusting under normal use, right? But it can happen. We've seen that. I mean, there's quite a few people that have even lost their lives in lithium fires, and very few of those are actually lithium iron phosphate cells.
Mm.
I'm not a fan of the EV bikes and the lithium polymers that are coming out of China that are really volatile. But as far as we go with that, we haven't found anybody that could get our chemistry to catch fire. Now, if you go and you take one of these Group 31s sitting here next to me that's got a PVC plastic battery case, and you throw it in a campfire, yeah, the plastic's gonna go up, and it's gonna catch fire. The wires are gonna melt, the BMS is gonna be destroyed, but you will not see a thermal event coming from the cells themselves.
So it is because the lithium amount is very small. There are other things, that is non-flammable. I mean, this chemistry is not flammable. I mean, there is nothing in there, right?
Right.
Um,
So we just had our power wall, or I shouldn't say that, our wall unit, go through, and they light it off. They put heater pads in between the cells, and they get them up to like 2,000 degrees Fahrenheit to try to get thermal propagation. And we had a non-event. There was no thermal propagation. You can see in the infrared cameras inside the testing chambers that, yeah, there's a cell. It's glowing hot red, but it didn't go anywhere. And what
mm,
was left over was basically just a burnt cell. There's
mm,
no flame. So we go through 2,000 or 2,500 degrees Celsius testing, slowly heating up. There's no there's no flame reaction. It's kind of like burning metal, except most metals have a temperature in which they will go into a thermal runaway, which is measured by the increase of temperature higher than the temperature that's being applied, which is also possible with us.
mm,
So technically, we can go into a thermal runaway, but you're talking about 2, 3, 4 degrees higher than the heat that's being applied. But at the same time, there is still no propagation or flame event or anything of that nature. I think it might have to do, we've kind of been back and forth on this subject, but I think it might have to do with the amount of heat that's applied and molecules are escaping, whether it's hydrogen or carbon, whatever's off gassing in this event. That might cause enough friction squeezing through the cells and on a molecular level to generate a little more heat. In the Navy, we called that a class delta fire, when an
mhm,
F-18 would catch on fire, and it's made out of titanium and all sorts of fun stuff, in graphene out of trash.
mm,
So we can make the majority component in these cells. Eventually, I would like to source the graphene, if possible, from these guys that are making it out of trash.
mm.
So it's like the other side of recyclability, right?
Yeah,
So
I think,
recycling,
but I think you have to look at, I mean, I have talked to a lot of folks about graphene and many different sources, but the main thing is the scaling.
right?
If they can scale and they can provide something that is the grade or the quality that you need. So there are folks who are making it from the waste, the agriculture waste. And there are many different ways people are making it, but I think that they do not have the quality that actually can be used for certain application. But certain application like, construction and other where they are putting it in the rebar and all that, they are perfect. They can be used. But then everywhere, one of the thing which I say that is scale. Can they make it at a scale? At is very important, and then sort of like um, and the quality. So hopefully they can do. In
Yeah.
your case, does the quality matters a lot? I guess not. I mean, you can probably use the lower grade, right?
That's a question for one of my partners.
Mm,
I'm pretty sure we're using some of the best stuff that we can get our hands on right now.
yeah, probably you're not. Yeah, I mean that is something which I think would be good to know. I want to switch gear a little bit. I want to compare in certain applications. Like, one is how do you compare? I think you have something like Supercap, right? A hybrid Supercap, and how do you compare it to Tesla Powerwall? The home application.
So I mean, our 14.5 kilowatt hour unit competes directly with that product. However, ours is just a battery. So
Hmm.
you still need to go out and get yourself an inverter or, a solar or something of that nature so you can bring in from the grid and distribute to your house. So we do not have a built-in inverter.
Mm-hmm.
Um, our price is competitive, but our warranty is significantly greater. So for a $13,000 Powerwall installed, you get a 4-year warranty. I think they increase it to 10 if you allow them to monitor the battery at all times. Um, we're doing 15 years, just no questions asked, product guaranteed 15 years. If there's an issue, battery goes down, we're going to swap it out. And we
Hmm.
have confidence in that because out of all the hundreds of thousands of batteries that we do have deployed around the world, there has been no failures
Hmm.
except for those that were damaged by outside influences like tornadoes or flooding or technician error dropping something. Um, but comparatively, when you look at their product, especially when you tie them with solar, so from my understanding, you're taking DC from the solar panels
Mm-hmm.
being converted to AC, which is then being converted to DC again for storage, and then has to be converted to AC again to distribute through the inverter. So you've got all these back and forth between AC and DC, which lowers the efficiency.
Hmm.
So when we go straight DC to DC and then we're inverting once to power the house, that's when you start to see our round trip efficiency really kicking butt. And
Hmm.
that's, we're above 97%, but we know that we can get above 99% if we increase the thickness of the wires, right? Because the copper wires in between our battery and the inverter and then going to the wall, that's where we're going to have our measurable resistance, which in turn generates heat and energy
Hmm.
loss. So my chief technical officer would tell you, dude, we can get above 99. We just got to make the wires bigger.
So this is a very interesting story. I think it's very good story. And you have already units that are installed and running at homes, right?
Yes, there's a few. We're just breaking out into that market right now. But if you look at the guys that brought me into this technology, the true engineers behind this, they've all got it in their house. We've got a great time of use case. I think you mentioned at one point, or we mentioned in our last conversation, which was on Honolulu, with a bunch of energy storage and and solar panels up, and we can monitor how it's working and how it's fluctuating, and that is the chief technical officer of my manufacturer. That's
Okay.
his. So
So,
yes, there's a lot of it being used as well with the FAA and the Army in certain places where they have off-grid, off-site cell phone or communications towers like the FAA weather cameras that aren't tied into the grid. They're running off of solar. So during the daytime, they're charging batteries as well as powering the camera, and at nighttime, they're just powering the camera.
hmm. So my question to you, I mean, you have mentioned a lot of different applications during
All
our
right.
talk.
Sorry.
And which speaks to your like you guys trying a lot of different applications, and which is it speaks about your startup. It's a great thing. I want to know where are you seeing it is making your solution is making waves, where it is being liked quite a bit, or is a very good fit.
Well, I mean, to be totally transparent, I'm not making waves anywhere, but the guys that brought me into this technology, they are making waves in the telecom and data center area. So I'm breaking out into other marketplaces to act as a distributor to OEMs
Mm-hmm.
for this technology.
Okay.
But I think we're going to excel in uh, go-karting, um, time of use in homes,
Uh-huh.
large scale, you know, 20 to 40 foot shipping container, solar fields. Um, there's all sorts of places. God, there's batteries everywhere. I'm trying to get the Department of Transportation and figure out where these guys are buying batteries because you know that every stoplight in the United States has two car batteries on it.
Oh,
So like,
really? I thought
yeah, I didn't know that. I was sitting at a stoplight. And,
they are like, without power
right.
many times.
So
So how
you know
come?
how they blink yellow? Like
Mm.
we saw all the
Oh,
time in Florida, they blink yellow even when the power's out to let you know something's wrong, or maybe they blink red to show you that it's now a stop, a four-way stop. So those lights are being illuminated by Group 31 automotive 12 volt batteries that are sitting in a little silver box on the side of the pole. So I
uh-huh.
saw those guys. I was at a stoplight and I saw two technicians open one up next to me, and I looked at it. It just looked like a telecom rack, you know, a bunch of wires and stuff. But at the bottom, there were two Interstate Group 31s. I was like,
Uh-huh.
okay, what are those batteries for? And I found out. So I would like to get our Group 31s in there because if we stick those in a nice place that's not being exposed to the weather, so we don't have to worry about the deterioration of the PVC or the case that the battery's, you know, housed in. I mean, we could easily do 10, 15 years out of those things. And these guys are spending millions of dollars, not just on payroll, but on, gas and just time to go switch these batteries out,
Mm.
especially when you get into the cell phone towers and the weather monitoring stations. You know, it might be a 4 hour 4x4 trail to get to this communications tower just so the technician can replace some dead lead acid batteries with 800 pounds of new lead acid batteries.
Mm-hmm.
So I think we're trying to tap a few markets. I haven't exactly just taken off in one direction. I'm trying to act as a supplier rather than just a one industry, you know, one solution deal because I think that anybody that's using batteries, like actually using batteries, there's a really good chance they could benefit.
No, certainly. I think this application of the lights is actually very fitting to you guys. I mean, I would say that why it is just blinking thing that it can just operate fully if the battery can provide that kind of energy, you know. So it's very surprising to me that they have not yet fully replaced it with some sort of light.
When it gets hot enough, that F-18 just burns on its own. It doesn't need the atmosphere. You know, they'll jettison an F-18 over the side of an aircraft carrier and throw it to the bottom of the ocean just because they don't really have the foam or the technology to put that fire out. So
Hmm.
it'll go down 10,000 feet to the bottom of the ocean and just burn.
Wow. That is money burning.
I mean, that's wasting money on defense is one of the reasons I got into this. So
Yeah.
HyCap Energy is my DBA to defense energy. And I'm still going after the military and the DoD because I know that they have high power weapons that they're trying to use for anti-drone stuff. And you know, the batteries on the market right now can't compete with what we can do there because
Mm,
every time we shoot down a $5,000 drone, we're
mm,
spending $2 million on the rocket to shoot it down.
yep.
So they're trying to get the directed energy weapons and the rail guns, the laser guns, whatever you want to call them, to a level to where we can actually deploy those for this threat, this global threat now with this drone technology.
Mm.
But the missing link is the stored energy to power that gun.
That's very true. I think this energy it takes a specific form. You have to provide so much energy in a short time, right? So that the power density is actually a very uh, uh, defining characteristic, right?
But
So
then you deplete the batteries for that system. Now you have to recharge them.
yeah.
but at what rate can you charge, the other chemistries so that you can shoot your gun again?
Yep.
These naval ships they're powerhouses. They've got
Mm.
multiple gas turbines. Some of them are nuclear. The limiting factor is we go back to the C rate. At what rate can we charge our batteries, which is essentially your magazine for the
Mm.
gun? Um, so that's
Friendship
I don't
is
want to
very
go off
good.
on a tangent there. I could talk about that stuff for a while.
No, I mean, I wanted to mention, I think that it is impressive that you have got already all the UL certification and also NFPA approval approved for supercapacitor hybrid batteries, right?
So we don't have all of them. We're working on it. So
Mm.
we've been putting our larger stuff through so that we can go through all the testing, pay the mafia tax, and then bring our smaller products or our lower capacity products through. And at that point, we don't have to do the testing anymore. We just have to pay for that. So when you talk about paying, $50,000 for 30 a piece for 36 products, you also add on the products that were destroyed, right? So we send a $2 million shipping container to UL to get lit up and get the certifications. I mean, you're throwing $2 million in the trash, but
Mm.
it's not though, because we'll make money after that. But that's where we are right now. So we've got cell level ULs. We've got certain modules have UL. Whether it's 810, 810A, 1973, we're chipping away at it. But like I said, that 14.5 kilowatt hour, 48-volt wall mounted unit went through one UL test last week, and that was the one where they try to light it on fire.
Mm.
So that's 9548, I
Mm.
believe. And then the next step is your 1973, and then the official 810A report.
Mm.
So it takes some time, and those guys are busy. So if we send them a battery, we got to wait 60 days, 90
Mm.
days for them to actually light it up.
Mm.
But yes, we are chipping away at the UL and getting everything squared away. Some clients don't care. Some guys they don't need UL,
You know,
depending on the application.
this is the our startup way of going at it, as needed. Why you want to, throw money at things that nobody wants, right? You don't need. So that's a smart way to do things. So I
Yeah, and you
agree.
got to remember too, we're a small company. My parent company is a small company, and this is the old school story. Basically, the guys that brought me into this were lighting it on fire with acetylene torches in the backyard, trying to figure out why it wasn't flammable, and
Mm.
then refining the chemistry. The first couple batteries, they're put together by hand in a garage, and
Mm.
it's blossomed into full scale manufacturing, multiple facilities, multiple companies involved, and we're talking like 6 years ago, but this is we're a small group, so we're slowly working our way into certain marketplaces other than telecom, because that's where my business partners that's where they work, is in the telecom space. So I'm trying to do all of the other stuff with the DoD and the go-karts and the large scale stuff.
No, so Steve Jobs says, right? A small group of motivated, highly motivated people can change the world. And I see that quite a bit. We at Infinita Lab, I get the opportunity to connect with these groups a lot because only those people who are doing cutting edge R&D, cutting I don't know what is happening to my voice, cutting edge R&D, they are interested in doing testing, different kind of testing, and I connect with them quite a bit, and I get the privilege of talking to them. And I see this kind of story a lot. Like somebody did these kind of tests in the backyard, but they are really very interested. They are burning with to bring it out, right? Something they figured out, something they discovered. And this is a great story, then basically you go through all these applications and everything. You are going through this hustle of all the applications that you can find. And I'm I'm very happy for this new technology coming up, which is a lot more safer for a lot of application, maybe where traditional solution would not work. And I think those application probably were waiting for you. That something comes up and gives them the energy density, continuity, or some other things that they were waiting for. I mean, they were using a you know probably a non-optimal solution for them, right? So this is great. Another thing I want to touch upon is sustainability, right? People are talking about uh, hazardous material, toxic materials, and especially rare earth that we are not getting here in US, or there are in short supply. So what about those things in the batteries, that battery chemistry that are you using?
So, I mean, like I said, we still have lithium in these cells. It's a very small amount, and it's in a form to where it's not flammable, right? So we lose the flammability. When we start to talk about sustainability and recyclability, we sent some batteries to a third party company that certifies you for recyclable or not, right? So they said that we were 100% recyclable. So when I say that we're 100% recyclable, 15, 10 years down the road, we might have a separate business model that is similar to what they're doing in China with the lithium, where city bus batteries come in and then you just, pull all the cells out, 50,000 cells out of these city buses. They test them, and the ones that hit the mark, they resell to other suppliers. And that's
Hmm.
where you get like your grade A, your grade B, and your grade C cells. So I look at that and, 10, 15 years down the road, if we get, a cell phone tower that's taken out by a tornado and we got some of our batteries are destroyed, but some of them aren't, we can take those cells out and put them back in another battery for a
Hmm.
different marketplace. So I
Hmm.
think we're going to see these things running a lot longer than we originally anticipated. Um, 'Cause that's where I look at it. I'm not too sure how that company determined that our cell pouches are 100% recyclable. I don't know if they have the ability to break them down or just turn the whole thing back into graphene. Because I'm pretty sure that you could take almost anything on Earth and heat it up to a certain level, and what's left over is essentially graphite, which you can make graphene out of.
Hmm.
Uh, which can be, there's some guys in Colorado that I really like. They're making graphene out of wastewater.
Hmm.
There's
Wow.
another group that's making.
Batteries that can actually have a higher energy density, so that it can basically run the whole show in the event of light going off. So it's pretty good actually in that case, and this is everywhere, all over US,
Yep,
every
there's
block,
batteries everywhere.
every
Semi trucks, dump trailers, security gates. There's backup energy everywhere, and there's functional energy everywhere. I didn't know how many batteries there were in the world, until I was 2 years into working in the battery industry. But it's a multi-trillion-dollar industry in a global marketplace.
That's
And
that's very true. And that's very true about different types of, I mean, it is eye-opening to me too. But I think you are right about Ryan, about also the B2C versus B2B. I mean, the home market is kind of B2C, and and other market when you're going after the government and all that, that is B2B, where you would, so probably you have to at some point choose something. And maybe
right.
you're already choosing, right?
Yeah, I mean, you'll never be able to go onto my website and just order a
Mm,
battery.
mm,
That's not in my business plan. What I'm for our home solar stuff, I'm actively trying to get in with the third party owners groups to approve our batteries to be used and sold to these, solar installers and electricians that get contracted to go do this stuff.
mhm.
So I'm trying to stay in that lane, as well as work on some other things in the background, with a deployment of manufacturing and moving stuff around. Um, I'm working with some people in Australia right now,
Mhm.
that have a really big need for batteries. They've got 4 million houses and with solar, and 5% of them have batteries. So
Yeah.
there's a lot of industries you'll find that are just kind of waiting around for something better to come out before they really jump into it. And that goes back to our conversation about this whole thing with lithium fires. A lot of people don't care and they'll stick lithium anywhere, which I do. Um, but there's a lot of folks out there and a lot of companies and governments that are scared to mass deploy lithium just because of what we see happening with all these different chemistries and fires and lithium plants in California catching on fire and destroying neighborhoods and releasing toxic gases into the environment. So that's kind of what's keeping them from fixing their problem with the current offering on the marketplace.
Hmm. No, and that is where you fit very well,
I hope
That
so.
in that story, yeah, it's impressive, Ryan. It is impressive to talk to you about this solution, which kind of like takes us in a very different direction, and but it is very good for a number of applications. Uh, I really wish you luck. I think this is something which we should keep in contact as well. But really wish you luck for making such a great product, which has a very sort of safe operations and safe longer operation, and can be applied to a lot of applications that actually need it really dearly. So appreciate that and thanks for coming to this conversation.
Yeah, thanks for having me. It's fun. I always enjoy talking about batteries. But the credit needs to go to the guys that developed this, my business partners and Supercap Energy. I'm just trying to sell it to other marketplaces.
I mean that is not a small feat if you think about it. That is probably the biggest thing there. I mean obviously making something is important, but also equally, I think selling it to different market and making them realize that this is a good solution is super important. Otherwise, there are plenty of great things that are there. They never saw the light of the day. Uh, I used to work for Corning, and Gorilla Glass was spotted by Steve Jobs. But otherwise, it was sitting there on the shelves for 30 years. Think about it. Now they are making windows out of Gorilla Glass.
Yeah,
Very high insulating windows out of Gorilla Glass. So, I mean, this is a very important work you're doing, and I really commend you for that.
thank you, sir.
Thank you. Thank you, Ryan.
All right.